Right now, without thinking about it, you are doing something no other animal on Earth can fully do. You are hearing these words. You are pulling meaning from sound. You are building a picture in your mind from nothing but vibrations in the air. And the reason you can do that is written into the physical shape of your brain, not as software, as structure. Your brain today is not the same shape as the brain of your ancestor from 2 million years ago. Language did not just teach your brain new tricks. It physically rebuilt it, expanded it, rewired it at the cellular level. And that process is still happening inside you right now. This is the story of how words changed the shape of your skull from the inside out. Go back roughly 2 million years. Your ancestor, Homo habilis, had a brain about half the size of yours. They made tools. They lived in groups. But their communication was closer to what you hear in a treetop full of chimpanzees. Calls, signals, emotional cries. Then something shifted. Researchers at the Max Planck Institute for Evolutionary Anthropology identified a mutation in a gene called FOXP2. This single gene controls the fine motor movement of the mouth, the tongue, and the jaw. In every other mammal, this gene sits quiet. In humans, it changed. And when it changed, the mouth gained a new level of precision, subtle movements, coordinated sounds. The raw, physical machinery of speech began to emerge. But the mouth was not the hard part, the brain was. Because to produce language, your brain does not use one region, it uses many. And it needs them to talk to each other at enormous speed. Neurologist Paul Broca discovered this in 1861. He had a patient who could understand everything said to him, but could not produce a single coherent word. When the patient died, Broca examined his brain. There was damage in the left hemisphere, in a region that now bears his name, Broca's area. This region is your brain's language production engine. It coordinates the sequencing of sounds into words, words into sentences, sentences into meaning. It is physically larger in humans than in any other primate, and it did not start that way. Over hundreds of thousands of years, as your ancestors began to use more complex sounds, Broca's area expanded, grew denser with neural connections, developed faster pathways to the motor cortex that controls the tongue and lips. Language did not use an existing brain structure. It grew a new one, but it did not stop there. On the other side of your brain, toward the back of your left hemisphere, sits Wernicke's area. This is where you understand language, where incoming sound becomes meaning, where you know that the word fire means danger and not just a pleasant arrangement of syllables. Wernicke's area and Broca's area are connected by a thick bundle of nerve fibers called the arcuate fasciculus. This white matter pathway does not exist in other primates, not in this form. In chimpanzees, the equivalent pathway is thin, small, and barely functional for complex sound processing. In you, it is a highway. Neuroscientist Nikos Makris at Harvard used diffusion tensor imaging to map the arcuate fasciculus across species. The findings were striking. The human arcuate fasciculus is dramatically larger, more elaborate, and more richly connected than in any other primate studied. It did not evolve for other purposes and get borrowed by language. It appears to have evolved specifically for the demands of complex speech. Your brain physically built a road between the two regions that process and produce language. And it built it over thousands of generations, driven by the survival advantages of being able to say more, understand more, and coordinate more precisely with other humans. Think about what that coordination meant. A group of early humans who could say, lion, behind the hill, moving left, survived situations that groups with only cries and gestures did not. Language was not decoration. It was a survival tool with the same life or death pressure as a sharp stone or a faster leg. And so the brain responded the way biological systems always respond to sustained pressure. It changed shape. By the time anatomically modern humans appeared roughly 300,000 years ago, the brain had undergone something remarkable. The left hemisphere had become dominant for language in most individuals. The temporal lobe had expanded. The prefrontal cortex, which manages planning and abstract thought, had grown dramatically larger relative to the rest of the brain.